So let's do exponential smoothing because we have too many information here. I'd rather start new, okay? So I'm just going to copy first 4 columns and I'm going to paste it into a new worksheet. And this time I would use exponential smoothing, okay, as a forecasting method, specifically for the case where alpha is equal to 0.5. So if you take a look at your lecture PowerPoint slides or lecture handouts, you see that the exponential smoothing is purely based on an equation. Okay, so I'm going to copy and paste this here. This is your formula for exponential smoothing. Okay, so what does it say? It says that your next period is equal to previous period prediction plus the alpha factor multiplied by the forecasting error. Okay, so you can pause for a second to see if you can understand this equation. Your prediction for next period is equal to the current period prediction plus alpha factor multiplied by the forecasting error, which is the difference between the actual value for the previous period and the forecasted value for the previous period. Okay, so the previous meaning the period right before the predicted period. Okay, so alpha here is somewhat arbitrary, and later I'll explain how choice of different alpha value can have impact. And this is essentially a weighted average as well, but you're now weighing different period. Your weighted average not based on different period, rather this is weighted average based on your previous forecasting error and previous actual value. So with that said, I'm just gonna start to do this. Okay, so for the first period, obviously you need to have first period prediction to be able to continue. Okay, so usually in your homework problem, the previous period prediction, which is YT hat, is usually being provided. Okay, but for this example, I'm just going to use the previous actual value, previous period actual value. Okay, and later you will see that the choice of the very first observation, very first value, isn't really a big deal depending on how you want to do that. So with that, I'm going to start my first prediction, which is predicted value for the previous period plus, okay, please forgive me, I didn't put my alpha value somewhere here. Okay, so with that, let's do it. Y hat plus, this is your alpha. I'm going to absolute reference this, multiply by your forecasting error, defined as the actual minus what? Actual minus predicted. So this is it. Okay, as you can see that because our second component here is going to be 0. Okay, so for the second period, you're getting exactly the same result, but from this point and below, it will give you different result. I think it's pretty good. Okay, let's double check to see whether we got everything correct. E19 is previous period prediction plus J1, which is your alpha value, and then you multiply the forecasting error, which is the difference between the actual value with the forecasted value in the previous period. Okay, now I'm going to explain the role of alpha and why I said this is another form of weighted average. Okay, so because this is already a lot of information, what I'm going to do is I'm going to move this to a new worksheet again. Okay, with that, I'm going to pick 5 different alpha value: 0.1, 0.3, okay, 0.5, 0.7, and 0.9. Okay, so I'm going to repeat the exponential smoothing here. First period, they're all equal to the actual value for the previous period. So this is the same. This is somewhat arbitrarily. Okay. Again, in this illustration, you will see that why the choice of those first estimation or prediction It's not a big deal. Okay, and with here, this one is gonna be your previous prediction plus an alpha factor, which I'm gonna multiply that with forecasting error, difference between those two. Okay, because we're gonna obviously drag it to the right, and then we're also gonna drag it to the bottom. But each time in each column we'll be using different alpha value. So I'm going to only absolute reference the row number here. Okay, row coordinate will be absolute reference. In that way, as you drag it to the right, the columns can change. It will become F, G, H, I. But as you drag it down, the row number will not be changing. So this will save us a lot of time. Okay. Okay. And also the other thing you need to remember is if I drag it to here and the E2, you need to move it to this position, because if you reference this value, this is not your actual value, but this is actually forecasted value under different value of alpha. So I'm going to move this again. I think to fix that, I can absolute reference the column. Let me see. Absolute reference the column only. Yeah, it will absolute reference column only, because you don't want those columns to be changing. But as you drag it to this direction, the row has to be changed. So I think this is a good implementation. Let's see. Let's drag it to the right and drag it all the way to the bottom. So I think, let's double check any random cell here. So it is G10, which is previous period prediction, plus G1, which is your alpha value, multiplied by the difference between actual with the forecasted value. Okay, so with that, I think we have completed the whole range of this forecasting or prediction. So like I said, the choice of alpha value, how would it impact your prediction? So I'm going to only use those first column and very last column to highlight the idea or demonstrate the idea. So I'm going to pick an extremely big number here. Say, for example, I'm going to multiply 100. Okay, I'm also going to multiply this by 100. Okay, as you can see that things has changed a lot in here. You can just rewind to see what actually happened here. Even though I picked a value that is 100 times bigger, the prediction here didn't really change much. Okay, right? It didn't change much. However, with this very first column, as you can see that the prediction has changed a lot. That's because there's a way you can rewrite. Your exponential smoothing formula. The first version of equation is original exponential smoothing formula. If you rearrange this formula a little bit, you'll be obtaining the formula you're seeing at the bottom. Okay, so what's the meaning of it? Meaning of it is alpha being applied to the actual value, and 1 minus alpha is applied to the forecasted value. So when you pick a really small alpha value here, that means you're giving much greater weight to the forecasted value. You're giving really small weight to the actual value. So 90% of the weight will go to the forecasted value. Only 10% of the weight will go to the actual value. That's the reason why when you see that when you pick a very big number here, the entire prediction has become somewhat very sensitive to your initial choice. But here it's a different story. It gives a lot of weight to the actual value, but it gave really small weight to the forecasting error. That's why even though we picked a really, really big value here, it didn't impact the pattern of prediction much for the rest of the values. Okay, so this is the exponential smoothing. I'm going to explain the trend projection in next video.